So, what are we cooking up in the kitchen today? Well, knowing my wiring, it's going to be spaghetti. Hi, welcome back to Warren OO9. I'm Mark. Well, the last video we installed the point motors on the baseboard. This is the Fiddle baseboard. So the next stage is wiring them in. So we'll see how far we get on with that today. I'm not going to obviously video me putting in every single wire, so most of that's going to be off camera, but what I will do is go through and I was going to use the words demonstrations, but that's a bit far out, isn't it? I'll just show you how I've done it, how I've wired up the point motors, and then explain some of my wiring and how I identify it. So let's get on with it. Okay, so here we've got a bit of handheld camera action. You can see the point motors that we installed on the last video. The green wires that you can see there come from the frogs on the points, and they have to be connected to the point motors, and we'll go into that in a little while's time. The red and black wires are not connected to the point motors. These come direct from the rails on the points. So they feed the DCC signal and the power to the point rails themselves. If we come up a little bit more, they follow through and are connected into these terminal blocks. So all the black ones are going into one terminal block, all the red ones are going into a second terminal block. From here, these will be both connected to the bus cable that's running around the layout. Now the red ones go into a terminal block and then direct to the bus wire, because these aren't involved in block detection. On the points on my railway, they are not included in the block detection, so we don't need to actually run those back to the detection devices. So what other wires are on here? If we come up a little bit more and along here, you can see some black and red wires just poking through the baseboard. These come from the loops of the fiddle yard. So the black wires are the common wires, the red wires are the ones that will be feeding back to the block detection device. So if we look here, sorry about the shakes, there's all the red wires ready to run through to go to the block detection, and all the black wires are going onto this block because they will just terminate and then go off onto the bus wire as normal. If I just slowly pan you around as well, we have got some more wires sticking out here, and again these feed the run-ins from the main line into the loops, and these will connect up, including that one. They will all go back to the block detection devices, and also the auto reverse. So this is the only conflict I've got. Back up on this one, I have used a yellow wire, and my coding is black and red for the normal feeds and the signals going through, and then yellow and blue for the power and signals to the point motors. So this is the only conflict, but if the cables are clearly labelled, plus it's going to be yellow and blue and not yellow and white for the points, we should get away with it. Right, you can just see little clips on there, so if I bring you in a bit closer and carefully, you will see that this says 13, and then there's a purple cable tie and a green one. So this is how I started to identify my cables. I might change that. In fact, I'll show you what I'm doing in a moment. Anyway, 13 is for point number 13. The purple cable tie is P for purple, so it's P for point. And then the green is, I've split my layout up into 4 power districts, and there's red, yellow, blue and green, and this is power district green. So combined together, it's the green power district, it's P for purple or point, and it's number 13. Just a way of identifying the cable. I have now got a printing machine, and I'm hopefully going to simplify this. Right, so this is the print I went for. It's the Brother H500 P-Touch. I quite like this. It's a bit bulky, but you can just about use it handheld. If not, you obviously just put it down on your desk or your table or whatever. It's got a nice array of symbols included on here as well. There's loads, electrical, general ones. It's just a nice variety. The fonts as well, you can get those in different sizes and different font types. So it's quite a versatile piece of equipment. The other thing on here is that the tapes come in different sizes as well. So this is about the largest one that will fit in the machine. This is 24mm or an inch. If I turn it sideways and put my finger against it, you can see how wide it actually is. Now you're not just limited to one line of text on here, you can get multiple lines. I think it's either 6 or 7 is the maximum you can do. But if you want a nice little label with a fair bit of information on to put on your railway, I think those are ideal. Now there's various sizes of tapes you can get. I think this is the smallest, which is 6mm or actually 5.8mm. Again, this one's in yellow. You can get loads of different colours. This is also heat shrink tubing. So this is what I now use to label up my wires, and I'll show you what I actually put on this shrink tubing to make the ID numbers. Right, so what do we do with this shrink wrap? As you can see from here, we actually print on the ID of the point or other device. So this device, or these devices, are in the green power district, denoted by the G, their points denoted by the P, and then the numbers identify exactly which point it is. The little dot between the number and the next G is simply a kind of an index point, a reference point for when I cut these out. If we just do it on the machine, you can print it into the machine and then tell it to cut. The only thing is, as you can see, it does quite a bit of waste on there. I could have got another 2 numbers in there, so that's to save. I just put a little dot there and then cut these off to the length I want. Now the other thing I've done is I've done 2 runs of numbers, so that one will go at the point end and the other number goes on the wire at the DigiKeys device end, and that's just so I can keep a note of which wires are which when I come to wiring them in, to make sure they go into the correct ports. Right, so that's how I'm going to identify each wire and where it should be connected to on the scenic section or the fiddle yard on the model railway. How do I keep a track of that? What record will I have to be able to look back in the future and find out where that actual device is located on the railway? It's okay saying point 13, but you know, where is point 13 on the railway? So what I've started to do is put a manual together. This is my little Bible about my model railway. Anything I've done so far, anything I plan to do in the future, and as I do work in the future, I will record it in here. And then I've got a permanent record of what's done, how I've done it, and where I've done it. So what is in here at the moment? If we turn to the back, there is just a brief history, kind of a backstory. This will come in handy when I start doing scheduling and running trains. If I want to do a timetable, what train runs where, what does it carry, what goods does it take, what goods does it collect. So as I say, that's good for scheduling in the future. Each of the locos has then got its own data page. It tells me where I bought it from, how much it was, what the serial number of it was, who made it. It's also got down here about the length and the weight of it, which again is going to be handy for making up trains in the future and make sure that they fit in the sidings I've got. And at the bottom there's just a little worksheet, whether it needs renumbering, whether it's got a chip in place, whether it needs a crew, just details like that, and I can tick it off as I do the work, and I know what I've done and what still needs to be done, because my memory is appalling at times. Now that runs forward, and we've also got that for the rolling stock. Now some of my rolling stock I've bought has got the same running numbers on it or stock numbers on it, so obviously I'm going to need to change those, so again it's in the little tick sheet at the bottom. What else is in here? Well, there's a bit about the helix, calculations for the helix, there's the helix, a bit about the turnouts, and then a bit help with electronics. This is actually printed off from Railway Scenics. It's a very good information. It's just a very good data sheet. It's been very helpful up to now. And then these sheets are the track testing. So we've got points and then just the normal blocks. And it's got a block number, what needs to be checked, when I checked it, whether anything needed to be, any remedial works that need to be done. This is what this needs updating, but it's slowly getting there. These are the devices from DigiKeys, and these are all the different connections that they go to. But for today, this is the most important page. Now, this is a schematic of the layout. It was produced from the Z21 app. I downloaded that and then put it into Word. When I had it in Word, I then went into Shapes and produced these blocks, if you like, and then colour coded them. So the blue power district covers the main Hazel Markham station and this little branch line off to the side, which I haven't decided what it's going to be yet. This is going to be the scenic sidings and the workshops for carriages and the locos. The green area is the helix and the fiddle yard, and then the yellow is the branch line that goes out to Holton, St Mary and the reversing loop and back. So that's the 4 power districts. We've also got the points identified on here. Obviously they form part of the schematics, but to identify them, their numbers are in red. Now the example I was using was power district, or the green power district, and point number 13, and point 13 is this one up here. So in the future, when I'm trekking through wires, I go find a loose wire or something, it says green power district point 13, I know where that runs back to, and I know which one that connects to. If I had a fault on it or an issue, then I can again trace it back. There's some other numbers in here, and these are in little black boxes. These on the Z21 app are actually platform numbers, but I've used them for the block numbers so I can identify which blocks I've got. So that's it. That's how I'm going to keep a track of what wires go where and what devices are where. So let's get back to a bit of wiring then. So, as you know from the previous video, this is what I've gone for, the DCC Concepts Cobalt IP analog point motor. So why did I go for this and not the digital version? Well, the digital version is easy to wire in, you just wire it direct to your bus wire. But originally I was going to go for solenoid motors, point motors, and to power those I bought in a number of the DigiKeys DR4018 accessory decoders. So if I use the digital point motors, I wouldn't need those DR4018s, which means they would either get stored away and be a waste of money, or I would sell them on and I would lose money on that. Also, these analog motors are slightly cheaper than the digital versions, so that's why I've gone for these, just really to save money and not to waste too much money. So how do these get wired in? Well, if you turn them over so that you look at their bottoms, what they've done here, DCC Concepts, is put a nice label on which tells you what each of the ports does. So you've got 2 DC ins, which is where your DCC connection is made. You've then got a FB/LED port, which is a feedback, so I understand that means you can wire it back to a mimic panel so that you can show that the point motor's worked or thrown the points the right way. You've then got 3 ports, which are S2L, S2R and S2C, which are the 3 I will be using. So the L is obviously the left, and that's your left hand rail of your point. The R is the right hand rail of your point, and the C is common, but that's the one that actually wires back to your frog. So as the point motor changes between the left and the right, it will change the polarity on your frog. Then at the bottom you've got another 3 ports, which are S3, L, R and C, and that's so you can fit another accessory onto there if you like a 2-aspect colour light. So again, as the point motor throws, it will change it from red to green and green back to red. Right, so here's the point motor ready for wiring up. As I say, I'm not doing it on the baseboard itself, because trying to reach around that and get the camera angles right will be a bit of a nightmare. So what I've done is just got a spare point motor. Say it's spare, this one will be on the main scenic part of the layout, but at the moment it's spare. So DCC Concepts say that we need to strip the last 10mm of wire, which I've done. I've also tinned them so that when I put them into the slots, I don't catch them, splay them out, have the odd strand of wire that's going to connect with another wire and give me a short. So those are tinned and they're stripped and they're ready to put in. As I say, being DCC, we are not worried about positive and negative, so either of these wires can go in either of the holes. And as I said, it's just as straightforward as pushing down, sliding in your wire and releasing. So there's one in, and again, all we've got to do is push down the catch, put in the wire. As you can see, they're going fairly easy, and release. So the other ones I've got to do is the black wire from the left hand rail down with the catch, in with the wire and release. Then just the red wire, which is the right hand rail, and then last but not least the green, which goes in S2C, down and put in, and that's it. It's as easy as that. I got my head around it anyway. Right, so there you have it. There's the point motor all wired up. The idea was to wire them up all identical, so that the black wire was always in the S2L and the red wire was always in the S2R. Now if I just quickly remove some of these wires, I'll show you what the problem was. And with my layout, there's always something gets in the way. So there, we've got rid of those. Okay, so as you can see at the moment, the black wires are on the outside, the red wires are on the inside. So the red wires feed the orange rail and the black wires feed the black rail. Now that's fine, and that's how I wanted it to be. It's just nice and tidy, and it just keeps everything in order as far as I'm concerned. The issue here is that all the points would have had to face the same way as they went round. So they always face in that direction. So you've got the wire and the actuator on this side, you've got the wire and the actuator here. The points face the same way. Here's where the problem came in. When I came to mount the point motors, the ones on this side would have been stuck over and trapping the frog wire that came up through the board. Now, I thought that was not a good idea, because if I need to change the point or change the wire, how am I going to get to it with one of these stuck over the top? So what I've had to do is wire these the other way around, or stick them on the other way around. So now I've got a black lead feeding the orange and the red lead feeding the black. We've got the black lead feeding the black and the red feeding the orange. So obviously on the points on this side and this 4, I have had to swap these over. So the black wire and the red wire. So the black wire comes out, the red wire comes out and goes into the left hand. And the black one comes in and gets connected to the right hand. If I can stop shaking long enough to do it. That's it, cool. So now we've still got the red feeding the orange and the red feeding the orange, the black feeding the black and the black feeding the black. It's just the connections here are opposite. Well, there you go then, there's all the wiring done on the fiddle yard. If I just come in a bit more, you can see I've used 2 colours. There's black and red, which is the DCC to the rails, and then there's the yellow and blue, which is the DCC connections to the point motors. Now, in one of the previous clips I said that over this end I had colour coded the wires to match the DigiKeys instructions for the auto reverse. When I was tidying this lot up, I realised that all that colour coded wire was 702 instead of 1602, so I've actually now gone through and replaced it. All the labels are in place so I can identify it, and I'll point out why that is really important in a second or two. There are some of these black wires that still got the old cable tie colour coding on, which I want to just change, so I'll do that next. And oh yeah, at the beginning of this video I said that we were in the kitchen and I wondered what we would be cooking up, and I said knowing my wiring it would be spaghetti. So just so not as to disappoint you, if I can squeeze through here, there we go, there's the spaghetti. Right, so that lot has all got to be tidied up, and the good thing is, as I say, with labelling up each wire at both ends, it won't be too much of a problem to match that up with the correct device when it comes down to wiring it into the DigiKeys DR4088s, 4018s and 5013s. Right, the next job is to test all this lot and make sure it works, and I'm going to leave that for another video, so I'm going to wind this one up now. Right then, there's the Fiddle yard baseboard, all wired up, point motors in, all labelled up, so hopefully I can find out which wire goes where when I'm putting it into the DCC devices from DigiKeys. So, as I intimated earlier, the next job to do is test that all this works, and I doubt it will. It's the first time I've ever done wiring like this, so there's got to be problems, and I say problems rather than problem. I'm going to find a load of things I've done wrong. I was working out how I could test this, what was the best way, and then I remembered that McKinley Railway had done a video on this some time ago now, and I've just looked it up, and it is their video number 18, which is operational reliability, testing track and electrics, and I've just noticed 4 years ago they put that on. Now I wouldn't dare put myself in the same league as McKinley. Mine's just a beginner's layout, very small, so nowhere near as the class that theirs is. But the testing they did was fairly basic, and it would relate to any model railway. So I'm going to have a go at that and check that this is right before I install it. I need to do that. Not only is it going to be in an awkward position, it's also going to have the helix built into it, and once that's done I'm not going to be able to get to a lot of it, so I need to know that this is reliable and works properly before I put it in place. As I say, that's the next job. I'll video that, and that should be out in a couple of weeks or so. For now, I've got to tidy up the kitchen. The wife's back tonight. Good job is she doesn't look at these videos, so I might get away with it. I doubt it, I'm quite honest, so I'll let her know what I've been up to. But yeah, so until next time, enjoy your model railways. If you found something interesting here, please subscribe, and I'll see you next time. So bye for now.